All right, so we are going to work on number 4 right now, and I have two students here helping me with this problem so that they can ask any questions, and they're going to help me, see if it's clear. So let's go ahead and begin with question number 4. This is on page 300, and we're looking at um, question 4, which is part or comes from lesson 6.4, which was in writing a number as the product of its prime factors. All right, can I have a volunteer to read the problem for me? Vanessa, go ahead.
Philip has 80 songs on his MP3 player. Complete the diagram by using the tiles to write 80 as a product of its prime factors. You may use a number more than once or not at all.
Great. So we are going to circle important information. So he has 80 songs, right, in his MP3 player. And we need to complete this diagram, which is finding the prime factors for 80. And this we can use these, not that we don't have to use them all, like it says, but we have to choose from here. So when we're factoring or finding the prime factors, remember that we're finding the factors, which is two numbers that we multiply to get um, a product. So the product is 80, and I need to find one number because they already provided the 2 for us. So 2 times what number equals 80? What would that be? Rosa?
40.
40, right? Because 2 times 40 is equal to 80. So once I hit a number that is already prime, remember that a prime number is a number that you only have two factors, the number and itself. So if once you have a factor that is prime, then you will just carry that same number down. So 2 is the prime number, right? Because you can only multiply 1 times 2 and you get 2. So that's the reason why they just keep writing 2. So that means that here we're going to have 2 and it goes down, and that's one of our factors that we will have as an answer. But 40, is 40 a prime or a composite? So remember, composite number has more than two factors. Is 40 a composite number, Vanessa?
Yes.
Yes. Okay, so that means that I can break it apart. And so they already gave us a 2. So 2 and what number equals 40? Student 2?
5 times 9? Or no, 5 times 8.
5 times 8, but they already gave us 2, right? So we're going to have, because of this problem, they already gave us 2, we would have to find 2 times what number equals 40, which would be what? You can also think like 2 times what number equals 4, and then just add the 0. So what would that be, student 2?
It would be 20.
20, right? So that would be, and so here we have a 2, which is a prime number. We're going to just rewrite it because we cannot break that number apart anymore because it's a prime number. But can we factor 20? Yes, right? So what would be, so they give us, I think I wrote on it. Again, they give us 2 as one of the factors. So what would be 2 times what number will equal 10? Student 1?
10.
10. So we have a 2 here. We're going to just bring that down because we don't have any more factors other than 1 in itself. It's a prime number. And we have 10. Can we break apart 10? What two factors make 10 other than 1 in itself? Student 2?
5 and 2.
5 and 2, or 2 and 5. And 2 is a prime number, and 5 too, right? You cannot multiply two other numbers to get 5 other than 1 and 5. So our final answer is 2 times 2 times 2 times 2 times 5. And that's how we do number 4. All right, so we're going to do number 5 now. And go ahead and read it for me, Rosa.
Write 2/5 and 1/3 as equivalent fractions using a common denominator.
So we're going to be finding the equivalent fraction. That is our keyword in this problem. Equivalent fraction. Let me change the color of my pen. So I wrote here the fractions 2/5 and 1/3 because that's the equivalent fractions that we need to find. Now, how do we find the equivalent fraction? What will be our next step, Vanessa?
I'm trying to find how much does 2/5 equal to 10.
Okay, so we need to find the equivalent fraction. So that means that we need to find and it tells us, right? The problem tells you using a common denominator. So we need to find the common denominator. How do we find the common denominator?
We need to find the multiples that are the same.
We need to find the multiples that are common, meaning that they're the same. So here on the top or on the side of your paper, wherever you're working, you will have to write the multiples of 5 and the multiples of 3, which are your denominators. So I'm going to write here 5 and 3. So my multiples of 5 would be 5,
10, 15,
15,
20,
20,
25.
25. And then 30, right? We'll stop right there. Now give me the multiples of 3.
3, 6, 12, 9.
9, and
12.
then 12, and then 15, 15, right?
15 about 6.
Add 3, that's 18. 21. I'll stop right there. I think that's enough. So what is our common multiple, Vanessa?
15.
15, right? And so it's common multiple because it's on both the multiples of 5 and the multiples of 3. So 15 is in the multiples of 5 and multiples of 3. And that is my smallest one. So I want to use 15. So when I'm going to find the equivalent fraction, I'm going to use that common multiple, which is 15 for both. And so when I say I'm finding the equivalent fraction, that means that I'm finding a fraction that is equal to 2/5, but with a denominator of 15. So now when I find the equivalent fraction, I'm going to say, I'm going to multiply 5 times a number that will equal 15 because I want it to equal 15. And that same number, I will multiply it. That same number, I will multiply it to the numerator. So 5 times what number equals 15? Go ahead.
3.
3, right? So 5 times 3 equals 15. If I multiply the denominator by 3, I have to multiply the numerator by 3. So 2 times 3 is equal to 6.
6.
And now I'm going to do the same process at the bottom. But now I need to find what will be that number that I multiply both numerator and denominator. And I look at my 3 times what number equals 15. And I will multiply it on the top as well. So 3 times what number equals 15? Go ahead.
5.
5. So I multiply the numerator by 5. 1 times 5 is equal to 5. So my equivalent fractions here, my answer will be 6/15 and 5/15. For this exercise, it will be okay if you leave it, if you don't simplify it. Okay, just for this problem, it's fine. All right. Any questions on that problem, number 5?
No.
Excellent. All right, this is question number 6. Can you go ahead and read it for me, Vanessa?
Okay, you brought 2 1/3 boxes of carrot muffins for a bake sale. Mike brought 1/3 boxes of apple muffins. What is the total number of boxes of muffins you and Mike brought to bake sale?
All right, so again, because when we have word problems, we want to underline the information that we're going to use. For number 6, just take note that this is part of lesson 7, where we're just adding and subtracting mixed numbers. So Jill bought 2 1/3 boxes of carrot muffins. So we're gonna circle that, right? And then it says Mike brought 1 3/4. So that's another piece of information that we need to use, 1 3/4. And then the question says, what is the total number of boxes of muffins? So that is what I'm trying to find, the total number of boxes. What is the keyword here that tells us whether we have to add or subtract? Vanessa?
Total.
Total.
It means that we're going to add.
Yeah, so it means that we're going to add. So that means that we will be adding 2 1/3 plus 1 3/4. So I know that I'm adding, I'm ready to add, but what is my first step? Go ahead, Rosa. What is the first step?
We have to, since they're different denominators, we have to find the equivalent fraction for them.
Yes, so we need to find the equivalent fraction. So to find the equivalent fraction, we need to list the multiples of 3 and 4, right? 3 and 4. So let's go ahead and write the multiples of 3 and 4. Okay, so we're going to write the multiples of 3 and 4. So the multiples of 3 are 3,
6,
go ahead, 9,
9, and 12,
12,
and 18.
And add 3, that's 15, right? I'll stop right there. Now let's do the multiples of 4. 4,
8, 12.
And I already see a common one, right? So I can stop there.
Yeah.
Our common multiple here is 12, right?
12.
So I'm going to use 12 as my denominator. So 12 will be my denominator for my equivalent fractions. And remember that the whole number we will carry over, it will be the same. Oops, not a 2 there. So now I'm going to find what number can I multiply both. Okay, so 4 times what number equals 12? And I'm going to multiply that number to the numerator and denominator. So 4 times what number equals 12? Go ahead, Rosa.
3.
3, right? And if I multiply the denominator by 3, I multiply the numerator by 3. So 3 times 3 is equal to 9. And now let's do the top number. I do the same thing. I'm going to multiply both the numerator and denominator by a number that will give me 12. So 3 times what number equals 12? Vanessa?
4.
4, right? So 3 times 4 is equal to 12. And so if I multiply the denominator by 4, I need to multiply the numerator by 4. 1 times 4 is equal to 4. So 4 plus 9 is equal to 13. And then the denominator is 12 because I'm adding, right? So I just added the numerators. 4 plus 9 is 13. And then out of the whole numbers, 2 plus 1 is 3. Now, can I just leave my answer like that?
No.
No, right? Because I have here, this fraction is greater than 1. So I need to regroup it because there's a whole. I can take out a whole from here. And so the whole number here, if you think about it, I'm going to kind of like subtract one whole, which is 12 over 12. And what do I have? And then that whole, I'm going to add it to the whole number. So what is 13 12s minus 12 12s?
112.
112. And now if I add that whole number that I took out from the fraction and add it to the whole number, that's 3 plus 1 is equal to
4. 112.
So it's 4 and 112. So the answer would be 4 and 112 boxes of muffins. Any questions? Anything that look confusing?
No.
Good. Okay. So this one is just about regrouping, right? If I see a fraction that is greater than 1, and I know that because my numerator, the top number, is bigger than my denominator, the bottom number. Okay, that was question number 6. All right, we are on question number 7. Go ahead and read it for me.
The shaded part of the diagram shows what Jenny has left from a meter of string. She will use 3/5 meter of string to make bracelets. She wants to determine how much of the string she will have remaining after the bracelets for numbers 7A through 7C. Select true or false for each statement.
So we're going to be looking at A, B, and C, right? So there's 3 different questions for each problem. This problem, number 7, comes from lesson 2, which is use fraction strips to subtract fractions with unlike denominators. And so we have here on A, to determine how much string will be left after making the bracelet, Rebecca must find 9/10 minus 3/5. So it's asking whether it's true or false. So let's go back to the problem, read it closely, underline the important information. So here we have, this is a shaded part which shows what Jenny has left from a meter of string. So this is 1 meter. This is what she has left. She will use 3/5 meter of string to make bracelets. She wants to determine how much of the string she will have remaining. So she wants to know how much there will be left for making the bracelets. So if we know, so remember when we have word problems, it's very helpful to write that information that we have. So from the diagram, we can say that we need to find what fraction that is. Let's read that again. It says that the shaded part of the diagram shows what Jenny has left from a meter of string. So meter of string is equal to, what does this diagram represent? What fraction does it represent?
9/10.
9/10. And how do you know that?
It's shaded 9 blues, and then 1 is not shaded, so it's 9/10.
Yeah, so it's 9 out of 10, right? 9 out of 10 are shaded. So you would count the squares: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the question, the scenario says that she will use 3/5 meters of strings to make the bracelets. So that means that she's using 3/5. So would it be correct to say 9/10 minus 3/5 will tell me how much leftover she will have?
Yeah.
True, right? So that is correct. This statement will be true. I would have to subtract 9/10 minus 3/5. Okay, Now let's look at 7b. The fraction 3/5 and 6/10 are equivalent. Are they equivalent?
No.
Well, let's take a look. We're saying that 3/5 and 6 is equal to 6/10. So this is not on the problem. They're giving us 6/10. So that's where it might be confusing. But they're telling us is 6/5 this equal to 6/10. What do you think?
I think yes.
Okay, because if I multiply 5 times what number will give me 10?
2.
2, right? And 3 times what number equals 10? Is 3 times 2 equal to 6? I'm sorry?
Yes.
Yes, 3 times 2 is equal to 6. So that means that they are equivalent. Because if I multiply both the numerator and denominator by the same number, it gives me 6/10. So I basically multiplied 3 and 5 by 2. So 3 times 2 is 6. 5 times 2 is 10. So that means that the fractions are equivalent. They are equal. So that would be a true statement. Now let's look at the third at 7c. Rebecca will have 1/5 meter of string left. So now basically we need to subtract. And you could use fraction strips. We can go to fraction strips to do that subtraction. But I will not be checking your work, so you can do it however you want. But let's do it with toy. Oh, I don't have it. Actually, I should be able to do it here, actually. Let me pull the fraction strips. And we are subtracting. We are subtracting 9/10. So I'm going to take my 10 strips. So I have 1, 2, 3, 4, 5, 6, 7, 8, and they don't overlap that well. So wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I always want to put my one whole fraction strip on the top, so I have something to compare it, right? So I will put that one here. And then one more will be 10 out of 10. And so when I subtract, I basically put it under, right? So I'm going to subtract, we said it was 3/5, right? So I'm going to take my 5th fraction strip, put it under that. 1, 2, 3. And so whatever I have here left, that would be my difference, right? Because I'm doing difference. So basically, whatever overlaps is what I'm subtracting. Whatever's left is my difference. So what is the difference? Rosa?
Maybe try putting a 1/5 fraction strip.
I could, right? But I can already tell here that
Like it's
I could already tell, right, how much is it when I subtract, because every 1/10, every 2/10 takes up 1/5 of a strip. So I can already tell that my difference is how many tenths? 3/10, right? Now I could, like Rosa said, try other strips until I figure out how many fit under that. But I could already see the difference. So I would have, or Rebecca would have 3/10 strings left. Now Rebecca will have 1/5 meter of string left. Is that true or false?
false.
It is false. Any questions on that problem? Number 7.
No.
No. All right. Okay, so here we have number 8. Go ahead and read it for me.
For numbers 8A and 8C tell whether each expression was rewritten using the commutative property or the associative property. Choose the correct property of addition.
Excellent. So remember, the associative property changes the grouping. The commutative property changes the order. So remember, we did those hand signals. Associative property changes the grouping, and the commutative property changes the order. So on 8A, we have 1, 6 plus 7, 8, parentheses, 7, 8 plus 5, 6, close parentheses. And then we have an equal sign saying 1, 6 plus 5, 6, and in parentheses plus 7, 8. So we want to compare and see what changed. So what looks different on 8A? Rosa?
Well, I see that they're using different like places because the 7th, 8th plus 5, 6. I think it would be better if they did 7th, 8th, and 7, 8.
Okay, so basically here, isn't it just switched? The 7, 8 now it's here, and then the 5, 6 is now on the other side, right? So what did they do? Did they change the parentheses or did they change the order?
I think they changed the order because 1, 6, and 5. Actually, no, they changed the parentheses.
But parentheses is still grouping 7, 8, and 5, 6.
I think it's they changed the order.
They changed the order, right? All they did was switch what's inside the parentheses. So the parentheses are still grouping the same fractions. So this means that this is what property?
Commutative?
Commutative, because they only change the order. So the correct response here would be commutative property. Let's look at number B, or letter B. 7/10 plus 1/3, close parentheses, plus 1/10. And then they move it to 1/3 plus 7/10, and then close parentheses plus 1/10. So are they changing the order or they're changing what is being grouped? Rosa.
I think they changed the order because 7/10 was first, and now 1/3 is first there.
Yeah, right. They only switch the order of what comes first, but there's the parentheses is still grouping the same thing, right? So what property is that, Vanessa?
Commutative. It's still the same, just changing the order.
Yes, it's commutative because it's only changing the order. Excellent. And then 8C says 6 2/5 plus 4 ninths, close parentheses, plus 3 2/9. And then they're changing it to 6 2/5 plus, then parentheses 4 ninths plus 3 2/9. So what is changing here? The grouping, the parentheses, or the order?
The grouping?
The grouping, right? Because now the parentheses is grouping 6 2/5 and 4 ninths, but on the second one is grouping 4 ninths and 3 2/9. So that means that what's changing is the grouping. So what? So it's the associative property, right? Because the grouping is changing instead of the order. Excellent. Any questions?
No. No.
All right. The next problem is number 9. Go ahead and read it for me.
Okay. Joshua uses a rule to write the following sequence of numbers.
So Joshua's sequence, okay, when it's a sequence means that it's, a group of numbers, right? And so here our sequence is 1 6, 1/2, 5 6. Then there's a blank one that we don't know, and then it's 1 1/2. Let me go ahead and make this bigger. I'm not sure if you guys can see it clearly. I'm just going to make it a little bit bigger. Let me erase my markings. Okay, So he has a sequence here. Okay, and so we want to find what rule did Joshua use. So we want to find the rule. That is the keyword. And then we're going to have to find the missing number. So when we are trying to find the rule of a sequence, how would you do that?
First we need to find if they're subtracting or adding.
Okay, that is one way, right? First we want to see, is this sequence increasing or decreasing? Now, can we say or tell if we have different denominators? It's going to be a little harder. If we don't have the same denominator, it's going to be harder. So my first step will be to put all of my numbers in the sequence with the same denominator. That means that I need to find the equivalent fraction. Now, my two denominators that I have here are 2 and 6. So to determine which is the denominator that I will use to find equivalent fractions, I want to write the multiples of 2 and 6. So just writing two multiples of 6, 6 and 12. What are the multiples of 2? 2,
2,
4, 6. Right, 2, 4, 6.
8.
What is the common denominator? I can already see one, right? What would be the common denominator here?
6.
6, right? And that's helpful because that means that for 1, 6 and 5, 6, I do not have to find the equivalent fraction because it already has a 6 as a denominator. So all I have to do is find the equivalent fraction of 1/2. So the equivalent fraction with denominator of 6. So to find the equivalent fraction, I think 2 times what number equals 6?
3.
3, right? So if I multiply by 3 the denominator, I multiply by 3 the numerator. 1 times 3 is equal to 3. So 1/2 is equal to 3/6. So this means that in my pattern, I have, let me write it with the math tool so it's clear. I'm going to write it down here. That's too small. So I have 1, 6. My next value is, we just found out, 3/6. My next value is 5/6. It already has 6 as a denominator. Then the next one we don't know. So I'll just write a fraction symbol, but we don't know what it is. And then the last one is 1/2. But I already know what is the equivalent fraction of a half. So I could just write 1 and 3/6, right? There you go. So now we just need to find that first we need to find the rule. So now we can tell, is this increasing or decreasing?
Increasing, and it's adding by 2, 6.
Okay, so it's increasing because my numbers are getting bigger each time. So I know that it's increasing. So if it's increasing, is it adding or subtracting?
Adding.
Adding. So that means that part of my rule will be adding something, right? So it's add. How much am I adding by? And so there's different ways of doing this, right? I think one way is to go, okay, 1, 6 to 3, 6. What is the difference? Well, I can count 1, 6, 2, 6, 3, 6. So that means that I'm going up by 2, 6, right? Or the other way is to take the biggest number. So I analyze my first two terms. I'll take the biggest one, which in this case is 3, 6, and subtract the smallest, which is 1, 6. So 3 minus 2 is equal to 2, right? And I can verify that by comparing the rest. 3, 6 plus 2, 6. I'm sorry? Oh, so 3, 6, and then add 2, 6. Let's verify, right? We want to double check. If I add 2, 6 to 3, 6, 3, 4, 5. So that's correct, right? So that means that my rule is add 2, 6. Now, I want to find the missing number. So I'm going to edit this. So to find my missing number, I need to add 2, 6 to my previous term. So if I add 2 6 to 5 6, that is 5 7 6. Now 7 6 is a fraction greater than 1. So I would actually have to rewrite it, right? So what is 7 6 equal to? Oops.
Oh, since 7 already passed 6 6, it is 1 whole and 1 6.
Yeah, and I do that by subtracting 6 over 6. So 7 minus 6 is equal to 1. So I have 1 whole and 1 6. So that missing term is equal to 1 and 1 6. All right? And
I can have a question.
go ahead.
You did 1 6 because you subtracted it by 6 6, right?
Yes, I pretty much converted 7 6 into a mixed number. So 7 6.
Yeah, I was just a little bit confused because I didn't see the 1, so I was just a little bit confused by that.
Oh, okay, yeah. 7 6 is equal to 1 and 1 6 because I'm taking out that fraction that is equal to a whole number, and we still have 1 6 left over. So these are answers. Okay, make sure you can always rewatch this video in this section if you're still confused. All right. And now we are on problem number 10. Problem number 10 is of lesson 1. So this is based off from our first lesson in fractions, which is use fraction strips to add fractions with unlike denominators. So basically, we're adding fractions with unlike denominators. Can you read it for me, Rosa? Or Vanessa?
I'm sorry. Jeffrey walked 1/3 mile on Monday and jogged 3/4 mile on Tuesday. How far did he walk on and jog on Monday and Tuesday combined? Use the titles to complete the fraction strip model to show how you found your answer. The fraction may be used more than once or not at all.
All right, and they actually provide kind of like the model of the fraction strips. Remember to always read twice. Jeffrey walked 1/3 of a mile. This is, oops, I don't want to use that pen too thick. So Jeffrey walked 1/3 of a mile. I'm circling that. And on Monday, and then on Tuesday he did 3/4. And we want to know how much did he jog combined, right? Monday and Tuesday. So that means that we are adding 1/3 plus 3/4. And we're using fraction strips to figure that out. You can check your answer by adding without the fraction strips, but make sure that you understand how to use the fraction strips. So remember that we always start off with our fraction strip number 1, right? This is the whole fraction strip. And we're adding 1/3, which is, I can tell that it's this first, right? This fraction strip is like 1/3. And this one is our 3/4. Okay, and so when we're adding, we are pretty much combining. I'm going to put it here using the manipulatives so you can get a better view. Basically, what we're doing is adding 1/3. So I'm going to pull my 1/3 strip. Okay, I'm repeating what's here, but I want you to see it with the fraction strip so it's clear what we're doing. So I'm combining 1/3 and 3/4. So I put 1/3 right now on my screen. And now I'm going to add 3 of the 4th fraction strips. That's 1, 2, 3. And so now we want to know how much is that combined. Like always, we want to put our whole one on top. So this that I'm modeling here is the same thing that we have here. Now, to figure this out, a little trick that you can do, kind of like a cheat sheet, is that if you think about what is a denominator, that's going to kind of help you. The least common denominator will help you figure out which strip will fit evenly under these so that you can add it because we want to know how much is 1/3 plus 3/4. But we want to use a fraction strip that will evenly fit in those two, all these strips, all these combined. Does that make sense? So here, the book actually provides it for you, right? If you count, um, how much fit under the 1, that's going to tell you what fraction strip fit exactly. We have 1, 2, 3, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you think about it, 3 times 4 is 12. So that's a common denominator. So now all I have to do is see how many fit under the combined fraction strips. So I have here 1 whole, right? I have 12 twelfths and then 1 12. So this is equal to 1 whole. That's why I'm using the whole fraction strip to combine it. And then 1 12. Or I can go here on my fraction strips and put them under and see how many fit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it's actually 13. Just that here, you have to be very, put it right on the spot so it doesn't, so that it fits evenly. There you go. Okay. So if I counted how many strips fit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? 13 twelfths, which is the same thing as, okay, if we remove 1 whole, which is 12 over 12, it's the same thing as 1, and then we get 1 left over, right? 13 minus 12 is 1. So the answer is 1 and 1/12 miles. Did that make sense? Oops.
Yes. Yeah.
Okay. So we want to write here that it's 1 and 1/12. All right, so that was number 10, adding with fraction strips. You could always verify by changing the denominator, writing the equivalent fractions, and adding it. All right, so here we have number 13. Go ahead and read it for me.
4 students spent time volunteering last week. The table shows how much time each student spent volunteering. Match each pair of students with the difference between how much the time they spent volunteering.
So we have in this table the time that each student spent volunteering, right? So we have Amy, Beth, Victor, and Cal. Amy did 4 and 5 6 hours. Beth 6.5 hours. Victor 5 3/4 hours, and Cal 5 2/3 of an hour. This question, I forgot to mention, number 13 is based off from lesson 8, which is subtract mixed numbers with renaming. So we're gonna match each pair of students with the difference between how much time they spent volunteering. So if we're finding, so they're giving us 2 names, right? Amy and Victor. We need to find the difference and pick, and find our answer here. Go ahead, Rosa, question?
When I was doing this one, I think all you have to do is really find out when you subtract them, if it equals that.
Right. So we're gonna subtract them, and we need to find that answer here because we need to match it, right? So let's look at Amy and Victor. Amy spent 4 and 5/6 hours. Victor spent 5 3/4. Now, if you're finding the difference, in this case, one number will go on top. People are screaming. What number goes on top? The biggest one, right? The bigger number. Yeah, what number goes on top when I'm finding the difference to subtract? I want to put the bigger number on the top. So in this case, I will put Victor's on top. 5 3/4. Because here the important thing is to find how are they different. So it doesn't matter which one well, it doesn't matter. I want to put the biggest one, but it's okay to put the biggest one on top. So in this case, 5 3/4 minus 4 5/6. That's what I'm subtracting. I need to find the equivalent fraction, right? So in 4 and 6, if I'm writing my multiples of 4 and 6, 4 and 6. Okay, give me the multiples of 4. 4.
8 and 12 and 16.
6 and 12, right? So my common denominator here is 12, right? So I cannot subtract until I have found the equivalent fraction. So I will carry over the whole number. That stays the same for now. And now I'm going to find the equivalent fraction with a denominator of 12. So now let's start with the top number. 4 times what number equals 12?
3.
3. 3 times 3 is equal to 9.
6.
3 times 3 will be 9.
Oh, 9.
9. Okay, and now we're going to do the same with the bottom one, right? 6 times what number equals 12? 6 times 2. So if I multiply the denominator by 2, I multiply the numerator by 2. 5 times 2 is equal to 10. Let me erase these numbers so that it doesn't look too busy, too much writing. So I'm subtracting this, right? 9, 10, 12 minus 10, 12. I cannot switch the numbers, right? At this point, I can no longer switch them. Can I take away 10 from 9?
No.
No, so what do I do?
You have to regroup from the 5.
Yes, so this 5 becomes a 4, and I add that whole number to the fraction. But when I add it, I need to write it as with a denominator of 12. So 1 is equal to 12 over 12. So what is 9 plus 12? Yes. 21, right? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 over 12. And now I can subtract 10 12s from 21 over 12.
Sure.
Okay, so now I'm subtracting from that. 21 12ths minus 10 12ths is equal to
1.
21 minus 10.
Okay. 11.
11, right? 11 12ths. And then 4 minus 4 is equal to 0, right? So Amy and Victor, we can match it to 11 and 12, right? 11 over 12, that's the correct one. So here's our first match. Yay, first one. Then the second one, we have Carl and Beth. So we're going to be subtracting 6.5 minus 5 2/3. So I'm going to do this over here on the bottom. Which one's bigger, Cal or Beth? Beth has 6 1/2. Carl 5 2/3.
Beth has more.
Yeah, so it's 6.5 minus 5 2/3. What would be the common denominator for this one? I can do it mentally, right? 2 times 3, 6. We can just do that. Or you can just write the multiples, 2, 4, 6, and then for 3 is 3, 6. So the common denominator is 6. Now, 3 times what number equals 6? 3 times 2. So, oh, I made a mistake here, right? 3 times 2. So that means that I multiply 2 times 2, and that is equal to 4. Now, what is 2 times what number equals 6 here for the first fraction? 2 times what? 3. So if I multiply that to the denominator, I need to do it to the numerator. 1 times 3 is equal to 3. So here are my equivalent fractions, and now I can subtract because I have it written down with equivalent fractions. So I'm subtracting, okay, I'm going to draw a line. Oops. 6 and 3, 6 minus 5 and 4, 6. Can I take away 4 from 3? No, right? So I need to regroup. The 6 becomes a 5, and I need to add this whole to the 3/6. How would that look as a fraction if I add a whole? I'm adding.
I'm gonna add 6, 6.
Yes, 6 over 6, because that is equal to the 1 to 1, which I'm taking out from the 6. So now 3 plus 6 is equal to 9, right? And that's over 6, and I'm subtracting 4, 6. So I'm subtracting from 9, 6. So what is 9? So remember, we only subtract the numerator. What is 9 minus 4?
5.
5. And the denominator stays the same. And then 5 minus 5 is equal to 0. So that means that it was 5/6 of an hour, right? For Carl and Beth. That's the difference. So we combine it, and we see 5/6 here. So we combine that. And then finally, do we really want to solve this one? Well, for this video, I'm not because of time. But you will solve it the same way, and that's the only left will be 3/4 hours. So when you do subtract and you check your answer, you should get 3/4.
You don't really have to solve it because it's there, so and it's the only one left.
Right. All right. All right, and this is question number 16. A long one too, kind of. So Tom exercise. Oh wait, who can read it for me?
Student number 1 can. Student number 1 left.
Go ahead.
I'll read it. Is it number 16?
Yes.
Okay. Tom exercised 4/5 hour on Monday and 5/6 hour on Tuesday. Part A. Complete the calculations below to write equivalent fractions with a common denominator.
So we already know how to do this. We've been doing this whole video. And they break it down really nice for us here. So let's go ahead and complete that, right? We have Tom exercise 4/5 hour on Monday, 5/6 on Tuesday. We have 4/5 here and 5/6 here. So let me make this bigger in case you're having trouble looking at it. Because it is kind of small. But you do have your books too. So you can also do it in your book. So we have 4/5, and we have to find the common denominator, right? So we want to write the multiples of 5 and the multiples of 6 because those are our denominators. So we're going to write the multiples of 5 and the multiples of 6. So here we have 5 and 6. So let's do the 5s. Ready? Go.
10, 15, 20, 25.
Oops, 25. Okay.
We can stop there.
Emily, can you be quiet? Thank you. All right, and then we have 6.
6, 12, 18, 20, 24, 30.
Wait, 24 and then 30. Oh, but we still don't have any common denominators. I mean, we need to go a little bit farther with the 5, right? 25, 30. And there you go. Bingo. Let me move this to the side. So what is the
Like
common
I said, you just say
denominator?
bingo. You just said it.
So what denominator am I using?
30.
30. Okay, so here our denominator is going to be 30. So I'm going to write it in the denominators of my equivalent fraction. And now I need to say, okay, 5 times what number equals 30? 5 times, I can look at my multiples, 1, 2, 3, 4, 5, 6, right? 5 times 6 equals 30. If I multiply my denominator by 6, I multiply my numerator by 6. 4 times 6 is equal to
24.
24. You always have your multiples here too to reference back to it, right? 1, 2, 3, 4, 24. So my equivalent fraction for 4/5 is 24/30. Now let's do the second fraction, 5/6. 6 times what number equals 30?
5.
5. 6 times 5 equals 30. If I multiply my denominator by 5, I multiply my numerator by 5. 5 times 5 is equal to
25.
25. Okay, 25/30 is my equivalent fraction for 5/6. So we completed part A, right? Now let's go down and see what B is asking, part B. How much time did Tom spend exercising on Monday and Tuesday combined? Explain, now you have to explain your answer. So we are combining,
So basically we're just adding.
and we're adding, right? So that word means to add. Okay, so we're going to add 24 because we already wrote it with this equivalent fractions. 24/30 plus 25/30. What is that equal to? Let's add 24 and 25, right? Can we do this mentally?
49. Yeah.
49, right? Add the ones, 4 and 5 is 9. 2 and 2 is 4. So that's 49 over 30. This is a 3.
Now for this problem, do we have to simplify it or we just leave it?
For this problem, we do want to, well, right now we do want to write it as a mixed number, right? Because right now it's a fraction greater than 1. And I know that it's a fraction greater than 1 because the numerator is bigger than the denominator. So in that case, yeah. So if I take away 30 from 49, I know that that will create a whole, right? So what is 49? Let me write it a different color. What is 49? Oops. 49 minus 30 is equal to 19. So that means that my fraction will be 1 and 19 over 30. And that is the simplest form already. Now,
so
no,
I just have a question.
Go ahead.
Why did we have to subtract it from 30 though? Why not the other number?
So basically right now I have 49 out of 30. So maybe I should just write it as a fraction. So I'm subtracting 30 over 30 because this is equal to 1.
Oh, okay.
So maybe it was my mistake for not putting the whole fraction, right? And so that 1 is what is now here, my whole number. So I'm taking out that whole number from the fraction greater than 1. And then equals 19 over 30. So this left over is this right here. And then notice that it says explain how you found your answer. So basically what you want to explain is that we added the numerators and get the same denominator. And then we regrouped, right? We took out the 30 over 30. So just make sure that you explain that as part of your answer. So we converted the fraction greater than 1. We made it into a mixed number. Now let's look at part C. Part C says, how much longer did Tom spent exercising on Tuesday than he spent on Monday. So now we're actually looking for, what are we doing here? How much longer did Tom spend? So what is the keyword here?
How much longer?
Yeah, how much longer? What does that mean? What operation are we doing here, Rosa? What do you think?
How much sounds like you're subtracting.
Yeah, we are subtracting, right? How much longer? That means we're comparing them. We're trying to find the difference. So that means that we are subtracting. We're subtracting 25. We want to subtract from the biggest one. And 25 is bigger than 24/30th. So we're going to subtract 25/30th minus 24/30th. And I got this from my problem here, top. 1/4 and 5/6, but I'm using the equivalent fractions. So 25/30th minus 24/30th. So what is 25 minus 24?
1/30.
So it's 1/30th. That because it's already an equivalent fraction, is easier to work with. So now we got our answer, which is what the difference is 1/30th, or I could say Tom. Wait, let's see. Tom is the 4/5, which is the 24/30th. So that means that Tom exercised 1/30th less um, on Tuesday than Monday, right? So he actually spent 1/30th more time on Tuesday. So for your explanation, you just want to say, because you have to explain how you found your answer. We found the difference from the time spent exercising. We subtracted the numerators, and we kept the same denominator. So our answer was 1/30. Any questions?
Nope.
All right. That was the end of this review. Thank you for helping me, Vanessa and Rosa.
No problem. This was fun.